Have the new video regarding reactions of alkenes, addition reactions of alkenes. So let's start with this new video. Addition of hydrogen. So the first thing, we can add hydrogen into any of the alkene and we can convert it into ethane. The conditions needed for this purpose are the platinum nickel catalyst and the heat. We can add hydrogen to the oils like sunflower oil or any other oil and we can convert it into margarine. This is the first chemical property of the alkene. Then addition of hydrogen halide HX. So we can add hydrogen halide to the any alkene and we can convert it into a halogen alkene. You can see here this one is a propene. By the addition of HBr, here we have 2-bromopropane. So in this way we can prepare a halogen alkene by adding hydrogen halide into an alkene. The major product is 2-bromopropane. Now what is the mechanism? The mechanism, as you see here, first of all, the H in the HBr, H plus will be formed because it is a electrophile here. This is electrophile. So the electrons are donated from the double bond to the hydrogen, and from the hydrogen, the electron donated to the bromine. So bromide ion is formed. Along with there's a formation of a secondary carbocation, and that secondary carbocation then react with the bromide ion to make 2-bromopropane. So you can go through the whole of the text, but simple, I have write the simple rule here simply. Hydrogen attached where there are less hydrogen atoms, and hydrogen attached to the carbon where there are more hydrogen atoms. So it's a simple rule for the formation of 2-bromopropane. Addition of steam. You can simply see here that this is a ethene in which the water is added in the presence of phosphoric acid to make alcohol. So the condition is presence of concentrated phosphoric acid. Addition of halogen. So halogen like bromine can be added into any alkene to make halogen alkene. You can see here 1,2-dibromopropane is formed. Sorry, 1,2-dibromethane is formed. The same thing is also used as a test. So basically the bromine water can change its color from orange yellow to colorless if there is a double bond present in the organic compound. The mechanism of electrophilic addition to the alkenes. Here, this is the text. The mechanism can be seen here. So basically, here it is electrophilic addition in which the electrons are donated to this bromine atom. This bromine atom which got the positive charge, and the bond between these two will also be breakdown. So from here, there is a carbocation form, and that after that, when the carbocation is formed, then Br minus provides its electron attached to the carbon atom. So this is a mechanism of the electrophilic addition to the alkenes. Oxidation of alkene. So there are two ways in which cold dilute acidified magnate solution. The first one, when it is added to the ethene along with water, there is a formation of diols. It's simple. Whenever we add cold dilute acidified magnate solution to the alkenes, there is a formation of diols. But if we add hot concentrated one, then if only like ethene like compound is there, then there is a formation of carbon dioxide, both carbon dioxide on both sides. If one of the carbon attached with one carbon atom or one methyl group, there is a formation of aldehyde, right, along which is further oxidized into a carboxylic acid. If one of the carbon contain two more methyl groups or two more ethyl group, whatever the case may be, it will be converted into ketone. So depend upon the type of the alkene, different products will be formed. Here we are. So hard concentrated acidified magnate solution KMnO4. So you can see here ethene connected to carbon dioxide. You can see here there is a formation of aldehyde which further convert into carboxylic acids, and here there is a formation of ketones. Here you can see in the same way there is a formation of ketone, but this CH2 convert into carbon dioxide because it contains only hydrogen. Here you can see there is a formation of ketone because with both of the carbon atoms there are two methyl groups are present. Then comes the addition polymerization. If we simply heat up alkenes, any of the alkene like ethene or any of the alkene, there is a formation of a polymer. In case of ethene, there is a polyethene formation which is a common plastic. Here you can see this is a propene, so polypropene is formed. In the addition polymerization like this one, you can see here this is also showing the addition polymerization of a small section of the polypropene. So in this way, a large number of different kinds of plastics can be formed just by adding up the monomers, and this is known as polymerization. A 3D displayed formula of a small section of the polychloroethane. Now this is another way in which sometimes we can add a halogen atom to make this one. This is known as PVC, polyvinyl chloride, and this is also a kind of plastic which is used to make the plastic pipes for the electrical wires. Now these are the tackling questions of the addition polymers, how we can make the repeat unit and monomer. Simple, you can see here that like this is a polymer, this is in this one, this is a monomer and this is a repeat unit. This is a polymer, this is a repeat unit. Here we have to add a double bond. You should know that if there is two double bond present, it will convert into one double bond in the product, and if there is one double bond, the double bond will be removed in the polymer. Now here we have the questions. Like this is the first question from GA21, Winter 21. And diketo acid is a compound with two ketone groups and one carboxylic acid. So this is a bit long question. First of all, we are treating here the first part when you are treating the excess of hydrogen and nickel catalyst. So both of them from the alkenes convert into alkenes and they are same group. Here we have, now here they are saying actually that whether they are different keto acids are formed or not. One of the keto acid is formed here, one of the keto acid is formed here, but one keto acid is formed here. So it means that B is converted to different keto acids, which is correct. Here we have, if we add bromine, how many chiral carbon atoms are produced? Here, 1, 2, 2, 3, 4. 4 chiral carbon atoms. 1, 2, 3. 3 chiral carbon atoms. So answer is B because 1 and 2 are correct while the third one is incorrect. Here we have another question. Which one is the correct mechanism for the addition of hydrogen bromide? So we have just studied the same thing at the start of this video. So you can see here this one, the electron donated to H plus ion, formation of carbocation, formation of halogenoalkene. So obviously B is correct. So double bond of alkene attack H plus ion, we join make alkene to make carbocation. So this is electrophilic addition. The bromide attack carbocation and attach with alkene. This is electrophilic addition. In option D, arrow is reversed, so it is incorrect. So answer is B. Here we have another question. Basically, this is a polymer. In the polymer, you can see there is single double bond. So as I have written here, as one double bond present in the polymer, it means that monomer should contain at least two double bonds and four carbon atoms. So D is correct. Here we have the end of the video. We will see you in the next video as soon as possible. Thank you very much. Allah Hafiz.